Hello everybody, my name is Hessam Mohammadi from Department of Computer Science, Aalborg University. The title of my presentation is about the probabilistic flex offers in residential heat pumps considering uncertain weather forecast. This is a joint study between some national and EU projects. In this study, we have three types of contributions. First of all, we use CTSM software to estimate thermal dynamic coefficient of the residential buildings with multi-temperature zone. CTSM is an open source software, and we use the building sensor data to train the CTSM. The second contribution is that we use UPPAAL-STRATEGO as an open source software to generate flex offers. So we use the minimum and maximum energy consumption patterns of residential heating system to evaluate the flexibility potential of the building. And the third contribution is that we generate flex offers considering the stochastic nature of weather forecast. In fact, probabilistic flex offers are generated in response to the weather condition uncertainty. This figure shows the general plan of the suggested approach. So first of all, we use the building sensor data. The data include indoor temperature and heat consumption of the heating energy system, and also the weather condition, including ambient temperature and solar power. All the building sensor data exported to CTSM software to estimate the thermal coefficient. So the outcome of the CTSM will be the heat resistance and heat capacities, which are called thermal dynamic coefficients. So we incorporate the thermal dynamic coefficients into the flex offer approach in UPPAAL-STRATEGO. In UPPAAL-STRATEGO, we aim to generate flex offers. The flexibility potential of heating system in residential buildings stems from the difference between a lower and upper threshold of indoor temperature. In fact, the occupants or residents of the building set a comfort temperature as a flexible bound, including minimum and maximum indoor temperature. So the maximum power consumption is related to the upper threshold of this bound, and the minimum energy consumption is related to the lower threshold of this flexible bound. And the power flexibility or energy flexibility is the difference between the maximum and minimum energy consumption. It's worth mentioning that we consider weather stochasticity by adding a Gaussian noise to the forecasted weather condition for the next few hours. For the thermal dynamic, we have used a three-state thermal dynamic. The three-state thermal dynamic include indoor temperature, envelope temperature, and heater temperature. There are many types of thermal dynamic to describe the heat flux between internal and external envelopes. But in this study, we have used these three states, and this equation is a general model for buildings with multi-temperature zones. As discussed, we have used CTSM software to estimate thermal dynamic coefficients. CTSM is an open source software developed by DTU Compute and is publicly available. So the input of the CTSM are building sensor data, including indoor temperature and heat consumption of the building, as well as the weather condition, including ambient temperature and solar power radiation. And finally, the output of the CTSM software are the estimation of thermal dynamic coefficients. These coefficients include heat resistance and heat capacity of the building. Probabilistic flex offers calculate flexibility potentials of energy systems in response to stochastic variables. In this study, we consider the uncertain weather data. Therefore, the flex offers fit the probability distribution functions for minimum and maximum energy consumption patterns. And finally, a success function evaluates the cumulative density function of the heating system. And this is the floor plan of the building case study. The building case study is extracted from Modelica software, and in fact, this is a digital case study, digital building. This is a 150 square meters building with 4 rooms, including a kitchen, a dining room, a bathroom, and a bedroom. There are different windows dimension and different envelopes with high quality concrete for the insulation. In this slide, the thermodynamic coefficients as well as the comparison between the actual temperature and the estimated temperature for 4 rooms are presented. Based on figures, you can see that the estimation accuracy for 3 rooms are very well out of 4 rooms, and the estimation accuracy is 1 room is a little bit lower than the other rooms. This room is kitchen, so the main reason is that we have some waste heat in the kitchen from refrigeration system and oven. So this waste heat is not captured by the thermodynamic in our model. Okay, so in this figure, you can see the temperature evolution and energy consumption of radiators in 4 rooms for the minimum energy consumption pattern. In fact, in this case, we set the indoor temperature to the lower threshold of comfort bound, which is 18 Celsius degree. And you can see that the software minimizes the energy consumption to reach the lower threshold of indoor temperature. In this slide, in contrast to the previous one, the FlexOffers software tries to maximize the energy consumption of the heating system. And based on the temperature evolution, the FlexOffers increases the indoor temperature to the upper threshold of comfort bound. And you can see that the indoor temperature increases after the initial point and the reaches the upper threshold of the bound. In this slide, first of all, probability distribution functions are depicted for minimum energy consumption, maximum energy consumption, and the success function. So you can see them in blue, red, and green lines respectively. Secondly, the table describes the average values for minimum and maximum energy consumption as well as the available flexibility. Based on the table, the maximum and minimum values of energy consumption are around 30 and 20 kilowatt hour. Therefore, the available energy flexibility is around 10 kilowatt, which is 43% of the optimal energy consumption of the building. To conclude the study, we can say that in this study, we have used 2 open source software, the CTSM to estimate thermal dynamics of buildings and the UPPAAL to generate flex offers. Both software are publicly available on their websites and provide great opportunities for researchers to develop their studies. The CTSM shows high accuracy in estimation of the thermal dynamics. It's quite fast and converges in less than 5 minutes for each room. So the CTSM is a reliable software to study building thermal dynamics. And the third point is that the flex offer approach evaluates flexibility potentials of energy systems in response to stochastic variables. This way, the energy systems are not necessarily limited to building heating systems. For example, the flex offer approach can be developed uh, to unleash flexibility potential of commercial refrigerators in response to stochastic electricity prices. And finally, thank you very much for your attention to my presentation.